Good day, Captain RODIENPACATV. Distance by two bearings principles. We're talking about sailing, and we are talking about the principle on how to solve the distances between two bearings and the different unknowns. Today, I'm gonna discuss in a very simple and practical manner a principle that is based in mathematics that every mariner should not memorize the formula. Now let's start the explanations. The principles of bow and bearing calculations is very simple. First bearing, okay, so you are talking about the first bearing, then also the second bearing, then the distance between a beam. This is actually the principle of bow and beam bearing. If you could see this one, if you would try to investigate, there are two triangles. Okay, so the first triangle I would like to show is this one. This is a right triangle. The second triangle is an oblique plane triangle. Okay, so first and the second. I'm gonna show you this one, and I'm gonna stop after the animation, because in my calculations, in my explanation in RODIENPACATV, this is actually animation based. Okay, so here you would see a right triangle. I extract that one. That is the face of a right triangle. Again, why it is called a right triangle? Because it is always correct? No, because it has a 90-degree angle. What is a 90-degree angle? It is an angle perpendicular to each other. Perfect one. It's a 90 degree. The second triangle is an oblique plane triangle. I show you. This is very clear. The right triangle, the oblique plane triangle, exactly taken from this one. I'm gonna extract from this one and put it here. This is, I'm gonna extract from this one. This is actually extracted from here. Right and plane. Let's go on and let's move. Let's start with the principles of right triangle calculations. I have already discussed in the previous vlog. Very simple. SOHCAHTOA. What is SOHCAHTOA all about? It's only a code. It's sine angle opposite over hypotenuse, cosine angle adjacent over hypotenuse, tangent angle opposite over adjacent. Basic principle is that angle A plus angle B plus angle C is always 180 degrees. This is the right triangle. And the right triangle is actually using a different formula. So, as a mariner, what you would like to memorize? You memorize only SOHCAHTOA for the right triangle. Very easy. Very easy. Let's go to the next triangle. First, just let me expound on the functions of a right triangle. So what are the functions of a right triangle? It's very easy. Once again, the functions of a right triangle, to show you this one. Okay, I like to explain you this one. The angle that has a 90 degrees is angle C. It's one with a perpendicular. Always, the side opposite of this angle C is what we call hypotenuse. Always. Now you would ask me, Captain, which is the opposite and which is the adjacent? And I would ask you the same question. I will throw back another question. Which angle you would like to use? Because if you're gonna use the angle A, this A, the opposite, which is red color, is this one. the opposite of angle A. And the adjacent of angle A is this one. But you would like to use for example, the angle B. What is the opposite of the angle B? It's very simple. This one is the opposite of angle B. And the adjacent is here. So depends on the angle that you like to use. That's why in my example, I color the angle A red. Okay, this angle A red. And the sides that would define them are also red. Opposite and adjacent. Okay, so let me go on by saying to you. So why this side, which is Alpha Charlie, it is named adjacent and it is named opposite? Because this side could be adjacent if you use angle B. This side could be opposite if you use angle A. Very simple. As simple as that. So it depends what angle you like to use. So these are the normal functions. So katowa, and these are the reciprocal functions. So actually, if you are practicing what I am practicing, I don't actually memorize the reciprocal functions. But if you can memorize more, because the reciprocal functions you can actually easily calculate, you can still solve. I will show you later. But for the purpose of discussion, cosecant is the opposite, remember, which is opposite over hypotenuse is actually sine, which is on the other side. If you reverse this one, it will be hypotenuse over opposite. The name will become cosecant of an angle. Okay? If also you are a cosine, which is adjacent over hypotenuse, if you're gonna reverse this one, the hypotenuse will become on the upper side and the adjacent with the lower side. The name is secant of an angle. Actually, it's just the same. That's why I tell you, I don't memorize this one. I don't memorize. I just memorize this one. I just solve it to transposition. Tangent is always tangent opposite over adjacent, but adjacent over opposite is cotangent. For the purpose of discussion, for the purpose of terminology, sine, cosecant, they're opposite each other. Cosine, secant, they're opposite each other. Tangent, cotangents. Easy. Now we go to the second triangle. This is very, very important. Why? Okay. If you look up again the animation, we go to this one, the first bearing and the second bearing. In our books, in our nautical school, wherever you are in the world, they will tell you some formulas in which you have to memorize. Not on my lecture, not on RODIENPACATV, but I will show you how. It is actually a sine law. It is just simply laws of sine laws, which says that the sine of an angle over the opposite side, okay, equals the sine of an angle over the opposite side. Sine A over C, sine B over B, sine C over C. Okay, let me expound. Angle B is here, okay, angle B. The opposite of angle B is the side B. Angle E is here, okay, the opposite is the side A. Angle C, the other one, is here, and the opposite is very simple, the side C. So the formula stipulates this one, sine A over side A, or depends on the unknown that you are looking, depends on what you are looking for, what the problem is looking for. I just told you the basic principle of calculations. This is the very foundations of the calculations of a nautical science and navigation, which I am telling you in this blog, RODIENPACATV. This is very important because I've been using this one effectively when I was a student and when I was also practicing as a mariner. Okay, so distance by two bearings. This is what they are teaching in the school. Port side bearing. You can remember? So I show you. Okay, first bearing. Okay, so if this is ship that is running from A to first bearing is the A going to C. So C is the lighthouse and the bearing is second bearing is B. Then what will happen? Okay, the ship runs here and they will indicate the distance abeam. The DC is the distance abeam, basic. The one is just the same of what I have shown to you. Now they are putting names like alphabets for us to remember. Then the starboard side bearing, which is very simple. The ship is here, starts at first bearing, second ship runs here, second bearing, the ship runs abeam, and it's here. Then we have all the names. Then what at school, our teachers made a definition. Angle A is between heading and the first bearing. Angle B is the angle between heading and the second bearing. Distance run from first bearing to second bearing is very easy. It's letter C. So okay, I just show you this one. This is very simple. This is a letter C, which is the distance run from first bearing to second bearing. Of course, the distance of the second bearing, which is B to C, is named as A, alpha. Okay, distance of a beam. So the letter B, Bravo, small letter B, is the distance when the vessel is abeam the lighthouse. Okay, so port side bearing. Now here comes the formula. A is the heading, B is the heading, second bearing. A is the heading minus the first bearing. B, okay, is the heading minus the second bearing. Okay, and C equals B minus A. Then here comes the formula. C, this is actually the distance run, speed times time interval. Then the distance of a second bearing is actually a sine law. Why it is a sine law? Because it's a small letter C times sine A minus big letter C. In our example later on, after this principal explanation, I will show to you a solution that you don't need to memorize this formula. All you have to do is to understand. Because during examinations, during at sea, you can no longer memorize or remember the formula. Your basic skill as a mariner would come in and you can still solve the problem. This is what I am teaching you. Okay, so let me go on with a standard bearing. Okay, so what standard bearing we have to... So starboard side bearing. So what a starboard side bearing? It starts with, again, angle A is the first bearing minus heading. B is a heading, second bearing minus heading. Then C equals B minus A. And all these kinds of formulas that our school has been teaching us. But in RODIENPACATV, in this blog, you will learn how to solve solutions beyond what we have learned from the school. Because the school taught us basic formulas like this. But I will teach you practical solutions and navigation. Fellow mariner, Captain RODIENPACATV, happy sailing, God bless, and watch for my many solutions and problems and examples in my next vlog. Thank you. Happy sailing.